We're given a differential equation, and we have to find the minimum radius of convergence. So first, let's find the minimum radius of convergence about the ordinary point. I'll just put ordinary point x equals 4. All right, so how do you do that? Well, first you have to find what's called the singular points for this differential equation. So to do that, you simply take this piece here and set it equal to 0. And then you can solve this by maybe adding 4 and then taking the square root on both sides. So we get plus or minus 2. So these are the singular points. These are the singular points. So we want to find the minimum radius of convergence. Well, the minimum radius of convergence is the distance between your ordinary point and your closest singular point. So if you draw a picture, here's your singular points, and then over here is your ordinary point. So the distance between your ordinary point and your closest singular point is 2, and that's the minimum radius of convergence. Again, r is the distance between your ordinary point and your closest singular point. Let's do another example so you see how it works. What if we change it? What if we say the ordinary point is x equals -7? So in this case, again, if you draw a picture, here's our singular points, -2 and 2. And our ordinary point is way over here, -7. So r is the distance from the ordinary point to the closest singular point. So in this case, r is equal to 5. Hope that made sense.